Welcome to the DIY Honda Garage channel. The DTC P0236 indicates a turbocharger boost sensor circuit range or performance problem for the 2023 Honda CR-V. When this code is set, it signifies that the output from the turbocharger boost sensor is not aligning with the outputs from the barometric baro sensor and the manifold absolute pressure (MAP) sensor under specific driving conditions. The turbocharger boost sensor plays a crucial role. It measures the pressure entering the intake manifold, allowing the powertrain control module, PCM, to adjust fuel delivery and air intake to optimize performance and efficiency. A proper functioning of this sensor is essential to ensure the engine performs efficiently and avoids damage. If the turbocharger boost sensor produces values that deviate excessively from the expected readings provided by the baro and MAP sensors, the PCM will identify this discrepancy, triggering the P0236 code and indicating an abnormal condition within the turbocharger boost sensor circuit. The error described by DTC P0236 revolves around a malfunction in the turbocharger boost sensor circuit, which is pivotal for maintaining engine performance. The turbocharger boost sensor measures the pressure of the air entering the engine's intake manifold, providing vital data to the PCM for fuel injection and ignition timing adjustments. It is crucial because an accurate boost reading ensures the engine can achieve optimal combustion efficiency and power output. The baro sensor measures atmospheric pressure, while the MAP sensor records the pressure in the manifold. If the outputs from these sensors do not correlate properly, indicating a malfunction in one or more of the components, the PCM flags the issue and triggers the DTC. A thorough understanding of how these sensors interact and their respective locations can help pinpoint the problem effectively. Identifying the underlying causes for DTC P0236 requires analyzing three primary areas. First, a faulty turbocharger boost sensor can produce inaccurate readings. If the sensor is damaged or has developed internal faults, it will not work correctly, leading to performance problems. Secondly, problems with wiring or connectors can disrupt electrical signals between the sensor and the PCM. Damaged wires or loose connections may cause the signals to be transmitted incorrectly. Finally, vacuum leaks in the intake system can lead to pressure variations that affect the readings of the boost sensor. It is crucial to inspect these areas systematically during troubleshooting to ensure all potential causes are considered and addressed. Several symptoms can manifest as a result of DTC P0236. The most immediate symptom is the illumination of the check engine light on the dashboard, indicating an ongoing issue with the vehicle's performance. Reduced engine performance is another common symptom, as the engine may not reach its optimal output due to the improper air-fuel mixture caused by faulty readings from the turbocharger boost sensor. This may be perceived as a lack of power, sluggish acceleration, or overall reduced efficiency. Additionally, drivers may experience turbo lag or an unusual delay in acceleration as the ECU recalibrates, attempting to compensate for erroneous sensor readings. Recognition of these symptoms is essential for timely intervention and repair. The first troubleshooting step involves starting the engine and holding the engine speed at 3,000 RPM without load, either in park, P, or neutral. This initial step is critical as it allows the engine to reach a specific operational state where the turbocharger can effectively function, and the cooling system, including the radiator fan, can also engage when necessary. After maintaining this engine speed, it is essential to allow the vehicle to idle for at least 8 seconds. This idling period will help observe any abnormal reading from the turbocharger boost sensor as the engine warms up and stabilizes, setting the stage for accurate diagnostics. After completing this step, the next phase can be approached, unless failure is duplicated. For the second troubleshooting step, a test drive is required for several minutes within the recorded range of parameters previously outlined. During this test, monitoring the Honda Diagnostics System, HDS, for the status of DTC P0236 is crucial. Parameters include engine speed, vehicle speed, relative throttle position, REL-TP, calculated load value, CLV, and accelerator pedal position sensor, APP. Observing these values will help determine if the boost sensor is operating correctly under load conditions. If the DTC reappears during this monitoring, it confirms the presence of a malfunction related to the turbocharger boost sensor circuitry, providing essential data to proceed further in the diagnostic process. The third troubleshooting step requires turning the vehicle to the on mode without starting the engine. In this position, the HDS should be accessed to confirm the values of both TC boost pressure and the barometric sensor readings. Normal conditions dictate that the TC boost pressure and baro sensor values should not differ by more than 26.7 kilopascal, which is essential for evaluating sensor functionality. If the readings exceed this threshold, it indicates a potential issue with the turbocharger boost sensor circuit. The next course of action would be to conduct thorough inspections of the wiring and connections, as well as the sensor itself, to diagnose where the failure may originate. For the fourth troubleshooting step, it is important first to note the TC boost pressure value present in the HDS data list before starting the engine. After recording this initial value, you will start the engine and maintain the engine speed at 4,500 RPM without load, ensuring the vehicle remains in a no-load condition. This step is critical, as higher engine speeds can significantly influence boost pressure readings. It is essential to monitor the HDS for TC boost pressure to ensure it registers a normal condition of less than 0.67 kilopascal. If the values exceed this limit, it again indicates a malfunction within the turbocharger boost sensor system, necessitating further diagnostic actions to determine the failure's root cause. Once repairs have been made to address the issues identified during troubleshooting, it is crucial to perform a final verification process to ensure that the repairs were successful. This involves rechecking the DTC status to confirm that P0236 is no longer present in the system. Following this, performing a final test drive is indispensable. This allows the technician to observe real-time conditions and validate that the turbocharger boost sensor and related systems function as intended. Ensuring the sensor readings fall within acceptable ranges reinforces that the sensor and circuit are restored to normal operating conditions. This careful conclusion minimizes the risk of recurrence and bolsters the vehicle's reliability. To prevent the occurrence of DTC P0236 in the future, regular maintenance and inspections are imperative. Conducting periodic evaluations of the turbocharger boost sensor can help in identifying any early signs of malfunction before they lead to a bigger problem. Additionally, inspecting the intake system for vacuum leaks is crucial. Even minor leaks can severely affect boost pressure readings and overall engine performance. Regularly checking the integrity of electrical connections within the sensor circuit reduces the likelihood of intermittent faults that can lead to DTCs. By implementing these preventive measures, you can enhance the reliability of the turbocharger boost system, ensuring optimal performance of the Honda CR-V. In conclusion, understanding the implications of DTC P0236 is essential for efficient vehicle operation. This error code signals a problem with the turbocharger boost sensor circuit, impacting engine performance. Following the diagnose troubleshooting steps methodically allows for precise identification and rectification of the underlying issue. Additionally, Regular preventive maintenance will contribute significantly to the longevity and reliability of the turbocharger system. By understanding its components, roles, and functions, you can ensure your Honda CR-V runs efficiently and reliably for years to come. Please like and subscribe to the channel. See you next time.